In this type of problems, we basically are asked to analyze the function and answer lots of different questions about it, using our knowledge about first and second derivatives. The function is 4 multiplied by x minus 4 raised to 2/3 plus 8. The first question asks about critical points. Critical points are coming from the first derivative. So let's differentiate the function. 4 is multiplied by 2/3. X minus 4 is now raised to 2/3 minus 3/3, which is negative 1/3. Plus 8 becomes 0. That makes sense. Now we want to find where this function is 0 and does not exist. For which x? A little bit complicated, but actually it's not. Let's rewrite this function. It's 8 over 3, and then we have 1 over x minus 4 raised to the 1/3. As you can see, I used the negative sign over here. It is never 0, right? Because the numerator is never 0. So the only critical points can come from the denominator being 0. Those are my D and E points. They're also called singular points. Singular points. You will see it in the literature at some point. X minus 4 raised to the 1/3 is 0 when x is 4. It is not a critical point if it's not in a domain of the original function. That's the definition of critical points. But the domain of the original function is minus infinity to infinity. So we can definitely say that it is a critical point. Very nice. We answered the first question. X equals to 4 is a critical point. If we are asked to find the actual point, which means input and output for the critical point, then you're supposed to substitute 4 into the original function, which is pretty simple for this case. It's going to be 4 comma, and then 4 minus 4 gives you 0. No matter what root it was, it's still 0. 4 times 0 is 0, so the answer is 8. 0 plus 8 gives you 8. Question B asks about where the function is increasing, and question C decreasing. So we're going to use the first derivative test. First derivative test. The way I teach it is I like to draw a sine line with x as the input that represents the derivative of the function. And that's why I like to put the derivative of the function into the box. Either this version of it or this version of it. Y prime equals. Now, put in the discontinuities, which we don't have any of the original function, and the critical points. We have 4. Here you go. Now, choose test points and check the sign of the first derivative. That's why I call it the sign line for the first derivative at those points. I guess 0 is a good choice for the left interval on the left, and the whatever 10, 5, you choose whatever you like for the interval on the right. I'm going to substitute those points into the box over there, into the first derivative. I only need to know the sign. So at 0, I can see, let me show you, 8 over 3 is multiplied by 1 over negative 4 raised to the 1/3, because 0 minus 4 is minus 4. Negative 4 raised to the 1/3 still will be negative, because it's the third root. And then negative multiplied by positive is negative. So this is the negative sign, a negative interval for the first derivative. Now, how about 10? Anything big minus 4 gives you positive. A positive number raised to the 1/3 is a positive, multiplied by positive is positive. So the original function, I'll even lift it higher. The original function will be decreasing from minus infinity to 4 and increasing from 4 to plus infinity. And this place over here at 4 is our local and sometimes even global minimum. That will be other questions to answer. So for B and C, I will answer. For B, the function is decreasing. Original function f of x is decreasing on, oh, the B asks about increasing. Fine, let's do increasing. I like to go from the left to right. I guess that's kind of more intuitive, more natural for me. Increasing on 4 to plus infinity. Don't include 4 because at 4 the function is neither increasing nor decreasing. Remember that. The derivative at 4 is 0. So the original function is not increasing nor decreasing there. And then its original function is decreasing on negative 4, negative infinity to 4, like so. Now we need to answer only 2 more questions, which is, where do we have local maximum and local minimum? Well, I already mentioned that right before that. For D, they're asking about local maximum. None. I don't see any local maximum. Remember, local maximum happens when we have a switch from plus to minus of the derivative because the original function is increasing and then decreasing. So we have local max. But we definitely see E, which is a local minimum. Local minimum happens when the sign of the derivative changes from minus to plus because the original function is decreasing and then increasing, then we have a minimum function. A minimum of the function. And it happens at x equals to 4. And we even figure out the output for that. So the appropriate and professional answer will be to mention 4,8. Remember that 8 came from me substituting 4 into the original function.